Alright, let's go over properties of quadratic functions. So, a quadratic function has this form, ax squared plus bx plus c. Okay, the most basic one is y equals x squared. This is a parabola, and it looks something like this. So it's symmetrical about a certain line. This one's symmetrical about the y-axis. Okay, but not all of them are. They could be anywhere on the graph. They could even be upside down. Okay, but if you look, it goes down, in this case, stops at a point, and turns back up. This is called the vertex, where it stops and turns the other direction. Also, the axis of symmetry passes through the vertex. So if you reflect it over this, it'll reflect onto itself. So if I make another sketch, this looks like it's the axis of symmetry right down the middle, and this spot right here is the vertex. And this is the axis of symmetry. Alright, so if we look at a graph, we could easily see the vertex, any axis of symmetry, but if it's something like this here, where it's not exactly on a particular tick mark, we might not know for sure what it is, but it doesn't matter because there's a way to solve it algebraically. Alright, so before we get into solving it algebraically, let's take a look at doing it on the calculator. So we have y equals x squared plus 4x minus 2. Now let's take a look at the graph of this. So here we see it goes down, stops, comes back up. So this area here is the vertex, and this line that goes up and down is the axis of symmetry that will be reflected over. Let's see if we can identify it from the table. So look at the table, see that we have different y values for different x values, and we see it looks like it's continuously going up here. Okay, so it's probably down further. Alright, now here we see it's kind of symmetrical here, so when it's negative 5 it's 3, but then when it's 1 it's also 3, when it's 4 it's negative 2, when it's 0 it's negative 2, then we have negative 5, and here negative 6. So this is the vertex, negative 2, negative 6. So if we were to graph this, we would have this point here is the vertex, and then this is the axis of symmetry. It passes right through the vertex and has the equation x equals negative 2. It's whatever the x coordinate is of the vertex. And it's going to go something like this. The exact points we could find from the table. So we would have 5, negative 3, 4, negative 2, and so on. Alright, so what if we don't have a graphing calculator? How else can we find this? Well, let's write down the equation of the graph again. It was y equals x squared plus 4x minus 2. So the axis of symmetry is x equals negative b over 2a. Remember, the basic equation or form is y equals ax squared plus bx plus c. So in this function, we have that a is 1 because there's no number written here, so it must be a 1. B is 4, the number in front of the x, and c is negative 2. So based on that, x equals negative b over 2a, so negative b, which is 4, over 2 times a, which is 1, gives us negative 4 over 2, negative 2. So x equals negative 2, which we already knew from looking at the calculator. So axis of symmetry is negative b over 2a, and then we can find out that x is negative 2 is the axis of symmetry. Well, how do we find the vertex? Well, the vertex is a point on the graph. So we could use the equation of, or the function to find out this point. We know that since the vertex passes through the axis of symmetry, that we could find the x-coordinate for this. We already know that's going to be -2 something. Okay, how do we get that something? Well, we get it from here. The y value is what this function equals when x is -2. So let's start with the function. Y equals x squared plus 4x minus 2. And we know that at this point, the vertex, x is -2, so we substitute it in. -2 squared is 4. 4 times -2 is -8, so we have -8 and -2. 4 minus 8 is -4, and -2 is -6. So it's -2, -6. And if we look back at our calculator, we see that from the table we found it to be -2, -6, just like the point we calculated.